Okay, so to start off this video, after I finish giving these instructions, I want you guys to pause the video and draw this picture. So draw it and copy it in your notes, that way you'll have it and it'll make more sense when it's in front of you. But I want you to copy the red and green lines with the points that I have into your notes. So copy those down. Don't worry about the blue line for now, I'll deal with that in a little bit. Alright, so I'm now assuming that you have those in your notes, the red and the green lines, drawn on your paper. We might be asked the question when we're dealing with graphs of lines, which line is the steepest? It's often helpful to be able to compare two lines and tell which one's steeper than the others. And when several lines are drawn on the same picture like this, you can probably eyeball it and say which one is going to be the steepest, just by looking at them. For instance, on this one, steepness is, picture if it's like a mountain. A steep mountain is one that'd be really, really tough to walk up. So out of the three mountains right here, my red one is probably not the steepest. Because if you look at blue, blue is tilted a lot further, as is green. But blue and green are pretty tough to say exactly which one is steeper. And furthermore, even if, like, when you look at them all together, we were able to say, well, it's not red. What if I give you three different pictures, and you couldn't just hold them right next to each other? It's helpful to have a way to talk about which line is steeper than the others. This is the concept of slope. So, definition for you guys. Slope is the measure of how steep a line is. So we want to know which graph is steeper than the others. And the basic idea that we're going to be using for slope, my favorite phrase for it, that you've heard before I'm sure, is rise over run. We want to know how much it's going up and down versus how much it's going left and right. We're going to put a number to that quantity. So if you want to find slope, you need to have at least 2 points. So you need to know 2 points in the graph. I'm going to look at my red graph first. And these 2 dots are conveniently already given to us. When you start finding your slope, start at the left point. So the further to the left on the graph that we have, and that's right here. And from that dot, I'm going to count first how far I have to go up and down, how far I rise, and then how far I go left and right, or run. So from here, I go up 1, 2. I went up 2. So I'm going to go ahead and put my slopes over to the side here. So the slope of the red is going to be up 2 over 1, 2, 3, 4. So 2 over 4. It's often helpful to reduce the slope. You'll usually leave it as a fraction, but you can reduce it to 1/2. And just in case you guys won't be writing in color, I'll call this line A. So the slope of A is going to be 1/2. Next up, I'm going to find the slope of my green line, which I'll call line B. So for line B, I'm going to start at my leftmost point, which is this guy right there. And I'm going to count first how much I go up or down. 1, 2, 3 down. Since I went down, that's -3. And then I went over, so after I go down 3, I go over 1. So it's -3 over 1, which is a slope of -3. When you go down, your top number is going to be negative. When you go up, your top number is positive. As long as you do my trick of starting from the left point, you're always going to be going right when you count, which means the bottom number will always be positive. It's just easier that way. If I would have counted this way, like I would have gone up and left, then my bottom number would be negative. But your bottom number will always be positive, assuming you start from the left. So I have one more line to go, and in this one, they didn't give us any points on it, unfortunately. That was kind of, it makes it so much easier when you can just count the slope like that. So what I'm going to do is they're called lattice points. Basically, I'm looking for a nice point on the graph where it goes right through a corner on the graph. Like if this was my line right there, that would be a lattice point. It's like right on the crosshairs there, and it's easy to tell what that point is. So if I'm looking at my graph right here, I see one such point down there. It goes right through that crosshair at -1, 2, 3, 4, 5, 6, -6, comma, -1. So you can draw that point on your own graph. And if I'm just looking at my graph here, I see another one right here. That would be the points 1, 2, 3, 4, -4, comma, 3. So once I get my points in place, I'm going to do my rise over run. I go up 4 over 2. So that was the slope of B. And for the slope of line C, I get 4 over 2. Which if I reduce that, that turns into just +2. So, with that being said, you may be asking yourself, well, how did you know to choose those 2 points? What if, like I saw this one right here, what if you just chose that point instead? Well, if you had done these 2 points, you would still have a rise 2 over 1. You get the same answer, actually. So it doesn't matter which lattice points you choose. It's just that sometimes, like with mine, I had to reduce before I got the same answer. So to answer our question now, the steepest line is going to be the one that has the biggest number. The biggest number for the slope. Not biggest in the sense of like a -3 is bigger than a +2. So the number with the biggest, or the slope with the biggest absolute value, is the steepest. So we don't really care about positives or negatives. We just care about the number itself. Absolute value means we make the number positive. Is steepest. So in our problem right here, our steepest line would be the green guy because it had a slope of -3. So that's how you find slope, by looking at a picture. And in the next video, I'm going to show you guys how you find slope using a formula as well.